Hi there, this is Mrs. Baxley with homework help for the mole test review sheet for the empirical and molecular formula problems. If you notice on your worksheet, empirical formula, number 1 gives us find the empirical formula for each of the following substances. And we have 52.0% zinc, so we're going to change that to grams of zinc. We have 9.6% carbon, so we're going to change that to grams of carbon. And we have 38.4% oxygen, so we're going to change that to grams of oxygen. Now we need to change each of these into moles is our next step. So we will set up our conversion charts for all three. And we need to know how many grams of zinc is in 1 mole of zinc. So we're going to look at our periodic table, and we're going to find from our periodic table that the number of grams of zinc in 1 mole is 65.382 grams of zinc in 1 mole. Now this is one on your periodic table that this 2 is in parentheses, but you go ahead and include that. So these will cancel out. Once we do the math, we're going to get that this equals, we've got 3 sig figs, so 0.795 moles of zinc. Now we need to know how many grams of carbon. So 1 mole of carbon weighs 12.011 grams. We do the math. 0.799 moles of carbon. Now I recommend you stop the video and see if you can figure out how many moles of oxygen you have, and then come back. In order to solve this, 1 mole of oxygen is 15.999 grams. Remember, you're not worrying about diatomics when you're doing these problems, because this is empirical, this is simplest. We're looking at atoms, not molecules. So when we do the math, this is 2.40 moles of oxygen. So we did our first 2 steps. Percent to mass, mass to moles. Now these are not all within 0.2 of a whole number. So we're going to divide by the smallest, which is this, 0.795, and we're going to divide all of them by the same number. Basically, we're trying to simplify everything by dividing them all by the same thing. So when we do the math, we get 1 mole of zinc. We do this in our calculator, that will round to 1 mole of carbon. And when you put 2.4 divided by 0.795, you get 3 moles of oxygen. We now have whole numbers. So our empirical formula is going to be Zn. There's only 1, so we don't put a subscript. Carbon, there's only 1. And we're going to have 3 oxygens. So ZnCO3 is our empirical formula. Problem number 2 is done the exact same way. Gallium is 34.6%, so we're going to change it to grams. Carbon, we start with 17.8%, change it to grams. Oxygen, we start with 47.6%, so we change that to grams. Then again, we're going to change each of these to the molar mass. 1 mole of gallium, once you go to the periodic table, that is 69.723 grams. I would suggest, once again, that you stop the video, see if you can do the rest of this. If you're stuck, then you can come back. Alright, 1 mole of carbon weighs 12.011 grams. And the molar mass of oxygen, 1 mole of oxygen, is 15.999 grams. Now we're going to do all the math and see what the numbers look like. We're going to 0.496 moles of gallium, 1.48 moles of carbon, and 2.98 moles of oxygen. These are not within 0.2 of a whole number, so we're going to divide by the least, which is this number. And what we do to one, we do to all. Do the math. We're going to get 1 mole of gallium here. We're going to get 2.98, which is close enough to 3 moles of carbon. And we're going to get 6 moles of oxygen. We now have whole numbers. Our formula will be Ga. There's one of those. Carbon, we'll need 3. And oxygen will be 6. So this is our empirical formula. Problem number 3. This is just coming about it from a slightly different perspective. It's giving you grams instead of percent, so this is even easier. 21.42 grams of calcium combines with 8.58 grams of oxygen. So we're going, we don't have to go percent to grams. We're going to go grams to moles. 1 mole of calcium is 40.0784 grams. Those will cancel out. 1 mole of oxygen atoms is 15.999 grams. Those will cancel out. I should have been canceling out up here as well. Every step we should be canceling out here. I do the math here. I get 0.5340 moles of calcium and 0.536 moles of oxygen. These are not within 0.2 of a whole number, so we're going to divide them both by the smallest number. Our answer is 1 to 1. 1 Ca, 1 O. Swap pencils. So our empirical formula is CaO. Number 4 is done this exact same way. I suggest you try number 4 on your own. If you're unable to get it, pause, come back to the video in a little bit. Problem number 4. It says 8,37, that's supposed to be 8.57 grams of barium and 4.43 grams of chlorine. Again, we're not worrying about any diatomics here, these are only atoms. 1 mole of barium weighs 137.33 grams. 1 mole of chlorine, I'm going to cross these out, is 35.45. Cross these out. I haven't actually done these in the calculator yet myself. 8.57 divided by 137.33. It helps if you turn the calculator on. Is 0.0624 moles of barium. 4.43 divided by 35.45 is 1.24 moles of chlorine. Now I may have done something wrong here. 4.43 divided by 35.45. Let's see. Yep, my decimal's off. I'm sorry for that. 0.125 moles of chlorine. So these are not within 0.2 of a whole number, so we'll divide both of them by the smaller number. This will be 1 mole of barium and 2 moles of chlorine. So our formula is going to be BaCl2. Molecular formula problems are done in the same way. We have to find the empirical formula first, and then using the molar mass we can then go to the molecular formula. So let's look at problem number 1 on a molecular formula. We have 42.9% carbon, so we're going to change that to grams of carbon. 57.1% oxygen, so we're going to change that to grams of oxygen. First we're going to change it to moles, so find the molar mass. Again, I suggest that you pause the video, see if you can find the answers. 1 mole of carbon weighs 12.011 grams. This is 3.57 moles of carbon. 1 mole of oxygen weighs 15.999 grams. When you do the math, you get 3.57 moles of oxygen. These are not within 0.2, so we're going to divide them both by the smaller number, and look at that, they're the same. So when we divide those, we're going to get 1 carbon and 1 oxygen. So our empirical formula is carbon monoxide. Now it asks us what is the correct formula, and it tells us the molecular mass is 28 grams. Well, if we add carbon, which is 12, and oxygen, which is about 16, that's 28 grams, so this is also our molecular formula. Carbon monoxide. Problem number 2 is done the same way. This time you have 44.6% nitrogen, and we're going to change that to grams of nitrogen. Once again, we're not worried about diatomics. 53.4% oxygen is going to be changed into grams of oxygen. And I'm going to actually let you complete the rest of this problem. I do have this, my answer sheet will be posted on Edmodo, so you can look and see if you did this correctly. Problem number 3 is 3 steps, so we're going to go to problem number 3. You complete to yourself, then you can go to problem number 3. Problem number 3, we have 10.04% carbon, so that's grams of carbon. We have 0.84%, so we're going to change that to grams of hydrogen, and 89.12% chlorine, so we're going to change that to grams of chlorine. We're going to find the moles of each of these. Stop the video and see if you can't do that part yourself. Alright, if you do need help, this is how you do it. 1 mole of carbon weighs 12.011 grams. So when you do the math, you get 0.8359 moles of carbon, 0.04 grams of hydrogen. 1 mole of hydrogen is 1.008 grams. So we have 0.83 moles of hydrogen. The chlorine, 1 mole of chlorine, is 35.45 grams. So when we do the math here, we've got 2.514 moles of chlorine. Now our problem here is these are both within 2/10 of a whole number, but this is not. So what we do to one, we have to do to all. It's all or nothing. So the smallest number here is 0.83. And we now have 1 mole of carbon, 1 mole of hydrogen, and 3 moles of chlorine. So our empirical formula is going to be CHCl3. It tells us that our molecular mass is 119 grams. Carbon is 12, hydrogen is 1.008, chlorine 35.45 times 3, so that fits in 119 grams per mole, so this is also our molecular formula. Hope this has helped.